So this is the editor tool, and we can start off by selecting a language to use, a graphical modeling language. So for example, PetriNet currently contains a place, which is represented by a circle, and an arc, which is represented by an arrow. But we are missing the transition concept. So let's go ahead and define that. So first we go to the configure panel. Then we select our language, and then we select the elements that our language consists of. And this basically represents this meta model of PetriNet, and we are missing this transition. First of all, I just want to show you how arcs or edges are represented or defined. So in Edge, we can see its preview on the right side, and then what we can configure in Edge. We can make it a double line, and we can define the color of the line as well. And we can see that in the preview. And then we can define the width of the line and other style properties, such as making it dotted, this pattern. And then we have these source markers, and the source marker we can define to be open, closed, or none. And we can do the same for the target marker. So now to define the transition concept, we can write the name of the element, and a transition is a node. And we can see here that a transition refers to the node concept through a supertype association. So let's add that so we can see a supertype, and we add it to the node, and then we add it, and we save the transition concept. But we can see here the transition does not have a graphical representation in our modeling language yet, so let's define that. We go to the draw panel, and we simply just draw our transition, and we add the connection points which Reactflow needs to connect edges to nodes. In Reactflow, we also need to define on which position these connection points are placed. Yes. So now we have defined that. We can also choose to add specific style properties to the square, background color and border, but we won't do that for this one. So now we can go back, and now the transition concept should be available in our language directly without generating the diagram editor code, and we can see that here. So now let's try to instantiate a diagram. First, I want to show you the instance model, that it doesn't have anything in it right now. But let's try to drag a transition onto the canvas. And we can see here that the instance model now contains a transition. And we can also see the layer, the graphical features that it has, the layers of features. So it has 4 connectors and a square. And yes, we can try to draw a more complete diagram. And then we can draw edges from connection point to connection point. The edges that we select from the language are the first one, but currently we only have arcs in this language, so we will always draw an arc. And then there can be specific attributes on the edge that we can define by double-clicking if it should look differently or such. And now I want to show you the custom constraint language in use. So if we try to add an edge between a transition to a transition, this is invalid. So when I do that, we will get invalid connection based on the constraint that we have added to the meta model. And yes, okay, so now I just want to show you how compartments work. And for this, I will select the UML class diagram language to show it with attributes. First, I will show you in the representation editor how compartments are added. So in the class, so first of all, we have a label on top, which refer to a local attribute of the class in the meter model. So this should be the name. So we will show the name of the class here. And then we have a compartment, which refer to a reference of the class. And here we have selected attributes with a vertical layout, so the attributes extend downwards. And yes, now let's see that in action. We can try to draw a class, and we will name it dog, for example. And we can see it is reflected. And then if we add attribute, let's say the name of the dog and then a string type, then we can see that here. And let's now add another attribute, for example age of the dog, which should be an integer. And now these are defined, and we can see that they extend downwards. And lastly, we can try to export the created diagram, and we can view it in a picture format. And this is the one.